The Mars 2020 mission is set to launch on Thursday, July 30th, 2020. Consisting of the Perseverance rover and the Ingenuity helicopter, this mission will aim to land on the surface of Mars on February 18th, 2021. The names Perseverance and Ingenuity were selected from over 28,000 essay submissions in the United States and its territories. The winning essay for the rover was submitted by 7th grader Alex Mather from Burke, Virginia, and the winning essay for the helicopter was submitted by Vaniz Rupani, a grade 11 student from Northport, Alabama. The chosen landing site for the Mars 2020 mission is Jezero Crater, an ancient 45-kilometer wide oasis on the edge of Isidis Planitia, a giant impact basin near Mars's equator. 3 to 4 billion years ago, Jezero held an ancient lake with clear evidence of flowing water, which deposited sediments containing clay and carbonate materials. Jezero's western edge was chosen as the landing site due to the ancient inflow of water that deposited materials. Similar deposits on Earth contain preserved organic molecules. This region on Mars may still contain some signs of ancient life. It will also be the first mission to Mars to collect core samples for future return to Earth. These chalk-sized cores will be collected by the rover and left on the surface for a future mission to find. A return of such samples to Earth would yield far more scientific value than even the most advanced rover could provide. The first launch window is on Thursday, July 30th, 2020 at 7:50 a.m. Eastern Daylight Time, though the full launch window is open until August 15th, 2020. Each day, the launch window will be open for roughly 2 hours, when the Earth's rotation places the launch site in the ideal position. The rover will launch from Complex 41 at Cape Canaveral Air Force Station in Florida, aboard an Atlas V 541 rocket, the same type of rocket that launched the InSight and Curiosity missions to Mars. After launch, the spacecraft will separate from the rocket and speed away from Earth at over 39,000 kilometers per hour. This will mark the beginning of its 7-month-long journey to Mars, traveling over 480 million kilometers. During this trip, specific milestones will allow mission engineers on Earth to tweak the flight trajectory and monitor the health of the spacecraft and its instruments. Each trajectory correction maneuver, or TCM, is a chance to place the spacecraft on the ideal path for Martian entry, descent, and landing. During landing, a similar procedure to the Curiosity rover will be used, with a heat shield, parachute, retro rockets, and sky crane tether. However, an improved landing technique will also be used. The rover will take images as it descends and compare these to orbital maps of the region to identify where it's headed. If heading for dangerous ground, the rover can shift its descent toward a safer landing site. The 2,260-pound Perseverance rover is similar in design to Curiosity, but with an improved suite of science instruments, which will attach along its 10 by 9 by 7 foot frame. SuperCam, a laser micro-imager. It can provide chemical composition analysis, imaging, and mineralogy. It can detect the presence of organic compounds in rocks and soil from a distance. Mastcam Z, zoomable panoramic cameras. An advanced version of Curiosity's Mastcam, it has panoramic and stereoscopic imaging. It acts as the eyes of the rover, identifying nearby areas of interest. MEDA, Mars Environmental Dynamics Analyzer. MEDA is the rover's weather station. It provides measurements of temperature, humidity, wind speed and direction, air pressure, and dust grain size and shape. RIMFAX, Radar Imager for Mars's Subsurface Experiment. RIMFAX is the first ever radar utilized on a Mars rover. This ground-penetrating radar can provide centimeter-scale resolution of the geologic structure of Mars's subsurface. This helps it to identify ice, water, and locations for core sampling. MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. MOXIE is an experiment to produce oxygen from the Martian atmosphere, 96% of which is carbon dioxide. SHERLOCK, scanning habitable environments with Raman and luminescence for organics and chemicals. And WATSON, wide-angle topographic sensor for operations and engineering. WATSON helps zero in on a target, allowing accurate data capture, and SHERLOCK's laser uses Raman spectroscopy to detect minerals in microscopic rock features. When superimposed over WATSON's images, scientists can decide the best targets for sampling to leave on the surface and hopefully return to Earth. PIXL, planetary instrument for X-ray lithochemistry. PIXL is an X-ray fluorescence spectrometer that will also contain a high-resolution imager to determine elemental composition of the Martian surface materials. Ultimately, it will give a more detailed detection and analysis of chemical elements in rocks than ever before. In addition to all these science instruments, Perseverance also has 2 microphones to listen to itself and its environment. It also has 23 cameras to see its environment and 3 communication antennae to send data and receive commands. It's powered by a multi-mission radioisotope thermoelectric generator, and it has 2 rechargeable batteries to help with high-power operations. The Curiosity rover discovered that the Gale crater hosted a lake billions of years ago, an environment that could have supported microbial life. Perseverance aims to answer the question, are there signs of past microbial life or biosignatures on Mars? The main science goals of the Mars 2020 mission are: determine whether life ever arose on Mars, characterize the climate of Mars, characterize the geology of Mars, prepare for human exploration. These goals are achieved through 4 main science objectives. Looking for habitability by identifying past environments that are capable of supporting microbial life. Identifying biosignatures, seeking signs of possible past microbial life in those habitable environments, particularly in special rocks known to preserve signs of life over time. Caching samples. Collect core rock and soil samples and store them on the Martian surface. Preparing for humans by testing oxygen production from the Martian atmosphere. As part of the mission, Perseverance will test the Ingenuity Helicopter in a 30-day window with several powered flights. The first flight will have the helicopter take off and hover a few feet above the ground for a period of 20 to 30 seconds. Since Mars is so far away, it takes several minutes for a signal from Earth to reach the red planet. This means the helicopter must be controlled autonomously, with all the flight commands sent in advance. Because the thickness of Mars's atmosphere is less than 1% of Earth's, the helicopter must be light and have fast spinning blades to generate enough lift for controlled flight. It does benefit from Mars's gravity, which is only about 1/3 of Earth's, but as expected, the helicopter weighs only 4 pounds, and its blades will spin at over 2,400 rotations per minute, about 8 times as fast as a typical helicopter on Earth. Ingenuity's main goals are fairly straightforward. Survive launch, cruise, and landing. Safely deploy on Mars from Perseverance. Autonomously charge itself using solar panels. autonomously keep warm during the cold Martian nights, which can get down to -90 degrees Celsius. These flights are important as they will test if similar technology can succeed in science operations on Mars. If successful, future helicopters could work in tandem with rovers and eventually humans, scouting locations for science data and sample collection at a distance, saving time and energy for the most valuable targets. They could even be used to map surface features. Hundreds of thousands of years ago, an impact on Mars sent rocks flying into space. One of these rocks, dubbed Se al-Uemar 008, is a piece of Mars that formed 450 million years ago. That rock made its way to Earth falling as a meteorite. The Perseverance rover will be taking this rock back home, using a small part of it as a calibration test for the Sherlock instrument as it analyzes collected samples. The names of almost 11 million people are etched on a microchip that is part of the Perseverance rover. This rover carries the hopes and dreams of people around the world as we seek a deeper understanding of the Red Planet and take the next step in human exploration of Mars. Thank you for watching. If you enjoyed this video, please press like and subscribe to our channel for more amazing space content.